Hi. Today we're going to be going over the Pythagorean identity in trigonometry. A pretty concise equation that's honestly really useful for solving all sorts of problems in trigonometry. So, what is it? Well, it's based in part on the unit circle. So here we have a segment of the unit circle here, and let's say we have, an angle theta here. Since this is a unit circle and this is a radius, this is 1. And we know that this x distance here is the cosine of theta, and this y distance here is the sine of theta. And they meet here at cosine of theta, sine of theta. Now looking at this, and knowing what we know about the Pythagorean theorem, we can say, well, the x value squared plus the y value squared has to be 1. Right? If this is the hypotenuse, this is 1, the x value plus the y value squared, both squared, have to be equal to 1. Well, we know the x value is cosine of theta and the y value is sine of theta, so we can say, in effect, cosine of theta squared plus the sine of theta squared is equal to 1. And on the surface, this might look pretty trivial, but this is actually an incredibly useful identity that can really come in handy for a variety of types of problems. For example, let's say that I'm given any sort of trigonometric property, especially if it's in the form of a sine or a cosine. Using this identity, I can easily find a different type of identity, or a different type of identity, and that seems vague. Let me try to make it a little clearer. All right, so say I have an angle theta, right, that I know is in the fourth quadrant, right? So if we're remembering our quadrant labelings, right, they go counterclockwise. So this is the first, this is the second, this is the third, and this is the fourth, right? So I know it's in the fourth quadrant, and I know the sine of theta is negative 24 over 25. And I'm tasked with finding the cosine of theta. This is actually not that bad at all. For something like this, you'd say, oh, I need a calculator. I'll need to put on and I'll need to find my inverse sine and then plug that into the cosine. But no, I can do it very simply without ever needing a calculator using this identity. I know the sine of theta is negative 24 over 25, so the sine squared of theta is just negative 24 over 25 squared plus the cosine squared of theta equals 1. We can, of course, simplify this out to get the cosine squared of theta is 1 minus negative 24 over 25 squared. And if I were to square this out and then take the square root of this and simplify, I have the cosine of theta equal plus or minus 7 over 25. You might say, okay, well, that's all well and good, and sure, I didn't have to use a calculator for that, but I'm still left with plus or minus, right? I can't have plus or minus for a single value, but here's what's helpful. We know that it's in the fourth quadrant, right? The fourth quadrant is right here. And all the x values, which correspond to the cosine values, have to be positive. So we know that for the fourth quadrant, we're going to have a positive cosine value. So the cosine of theta in this case is going to be 7/25. And that's where part of the beauty of this Pythagorean identity comes in. We can use what we know about a given trigonometric function value. In this case, sine of theta was negative 24 over 25. And without using a calculator, without using anything that we would need to use external resources for, just using this equation, we can find the cosine of theta. Or if we went even further, we can find the tangent of theta. And since we know the tangent of theta is the sine of theta over the cosine of theta, well, we know the sine of theta is negative 24 over 25. And the cosine of theta is 7 over 25. So we could simplify down to just negative 24 over 7, the tangent of theta. Or we could find, you know, the secant, the cosecant, the cotangent. Just by knowing a single sine function, we can unlock every other trigonometric function for theta given this identity. And this is why this identity is so powerful, because we can do all that without even using a calculator. So let's do another one for practice. Let's say I have an angle theta that's located in quadrant 3. And I know that the cosine of theta is equal to negative 3/5. So first of all, you know, want to remember what quadrant 3 is. The key thing here is to remember that the quadrant labels start in the first quadrant, where both are positive, and then they move counterclockwise, so in the opposite direction of where a clock moves. So this is the second, and this is the third, and this is the fourth. And we're looking for the third here in this case, so our x's and y's are both going to be negative. It's an important thing to keep in mind. We want to find the sine of theta in this case. So we're going to take this cosine, this negative 3/5, and we're going to plug it in to our equation. So sine of theta plus negative 3/5 squared equals 1. I'm going to move this all onto one side. So I have sine squared of theta equals 1 minus negative 3/5 squared. I'm going to take the square root of both sides. I'm left with sine of theta equals plus or minus 4/5 after simplifying this. However, since we know that this is in the third quadrant, where both the x's and the y's are negative, that means that all my sine functions are going to be negative. So in this case, I have negative 4/5. So for my answer, I know my sine value is going to be negative 4/5. And just like that, I use this simple identity to solve all of these variety of problems without ever using a calculator. So this is a real cheat. You know, when you're not allowed to use a calculator on a test or quiz or assignment, you can just whip this formula out and do so many things to make your life so much easier. The Pythagorean identity is also great for simplifying any equations that you might have with trigonometric functions in them, especially rational equations or fractional equations with them. Right? If I had like a trigonometric function or an equation with trigonometric symbols, and I found that the denominator after simplifying was equal to sine of theta plus cosine squared of theta, I wouldn't despair and say, oh, that's a complicated denominator I have to simplify. I can say, oh, that means that this is all over 1. So my answer is going to be whatever is in that numerator. Right? So just keep this identity in your mind, because it will show up in so many things involving trigonometry. It's such a useful thing to have. And when you're ever worried about remembering it, I always suggest just think about the unit circle, right? Remember, this is all based off of, this is 1, my cosines on my x, my sines on my y. So sine squared plus cosine squared equals 1, just like the Pythagorean theorem. In fact, that's why we call it the Pythagorean identity, because it's based entirely off of the Pythagorean theorem. We just happen to be using trigonometric functions because we're dealing with trigonometry in the unit circle. So that's the Pythagorean identity. I hope you found it helpful, and I hope you have a great day.